Hello, we are on page 41, and we are talking about graphing inequalities. And I don't think I need to update my table of contents. Yep. If you just want to call this inequalities, that's okay too. So, previously, in the first part of this chapter and in the integers chapter, when we talked about graphing a number, we meant on a number line. Like graph the integer and its opposite might have been, putting a dot on a number, and that was the integer. Then we turned it into coordinate pairs, which are really just two number lines intersecting. So we have a number line like I'm used to, another number line. This one just goes upside down, or not upside down, straight up and down. And now I'm plotting where things are in relation to both. So instead of like maybe 2 is here, but I'm doing 2, 3. And so I end up plotting a point that's in this open space. So then when we come back to graphing inequalities, people have this kind of graph in their brain, and we're really back to this. We're just talking about a number line. So when we graph an inequality, we're graphing a situation in which there is potentially infinite solutions that could work. We are just showing which solutions could work and which couldn't. So it's important to remember that when we're graphing an inequality, we're graphing infinite solutions. And so what we end up doing is we end up putting the line on all the things that could work as the answer. So this is just like the Desmos activity we did. That was like a whole bunch of dots. So we end up with something like this. Instead of just having a point, we have a point, and then we have, I'm going to do this in a different color. We have a point, and then we have the line, and then the arrow tells us it goes on forever. So let's say we start with something that a is less than 5. So there are infinite solutions to that. Any number that is less than 5, all the way down into the negatives, would work. So as I graph this, I start by making a line. I need to put some numbers on here. Maybe I'm just going to do 3, 4, 5, 7, 9. I'm keeping my scale the same. I'm just not labeling every number. So now I know that I need to put a point on 5 because it's all the numbers less than 5 that would work. So if I think about making an arrow, I want to show all the numbers less than 5 is what could work. So this is where I'm going to color in. Now this is where I have to pay attention because in this case, the number 5 does not work. 5 is not less than 5. That doesn't work. And so we need an open circle, meaning we want to show people this is the start of the solution set, but this number itself is not a solution. 4.999999999999999, that would work, but not 5. Okay? So this open circle tells us that this number would not work. It's not included in the set of solutions. We do this when it's just a straight up less than or greater than. So it's telling us 5 does not count. It does not work. Now we also might have something that's like k is less than or equal to 3. So same thing here. I'm going to draw my line. I'm going to put some numbers on it. 1, 3, 5, 7, 9. Okay. So I know it's going to be k is anything greater than 3. So my arrow is going to be all the numbers that are bigger than 3. And in this case, it says this line right here means or equal to. I talked about that in the last video as well. But so now, could I say that 3 is greater than or equal to 3? Yeah, because 3 is equal to 3. So now I'm going to have a closed circle, a filled in circle. So this is when you have that underline. And I want to give you one more to do and just try and see how you do. So this one I'll mix it up a little bit. I'll give you a fraction. So 0.5 is greater than m. 0.5 is greater than m. So hopefully you started with your number line. You know you need to put some numbers on here. Maybe you want to make these integers and put 0.5 in between. Maybe you want to make these 0.5s. Put 0 in the middle. Now I know that 0.5 is going to be right about here. And 0.5 is bigger than what m is. So m must be anything smaller than this. A good way to test is to pick a number on where you're thinking of going and see if it works. So if you're like, I think it's supposed to go this way, you could take like, will the number 2 work? So I rewrite the inequality and I put -2 in. I said number 2, I meant -2. And if this is true, it is true, then that means the arrow needs to head toward that number. Maybe if I thought it was supposed to go the other way, I could have plugged in +2. 0.5 is not greater than 2, so that doesn't work. That's not the way the arrow should go. So we have this, so now we put our dot and we need to decide whether to fill it in or not. Well, this is not or equal to, so it should be an open dot. Okay? Let's do one fraction one. P is greater than 3/4. P is greater than 3/4. Step 1, number line. Again, you could choose a different scale than me as long as your spacing always means the same interval between the numbers. Now, if I want to test it, I want to say, all right, I think, well, I know 3/4 is like right here. So I'm just going to put a little tiny dot so I remember where that is. And I think the arrow is supposed to point towards 0. So let me see if that works. 0 is greater than 3/4. Oh, nope, that doesn't work. So the arrow is not supposed to point towards 0. What if I make it point towards 2? 2 is greater than 3/4. Yep, that's true. So the arrow should be pointing towards 2. We always end with an arrow because it goes on forever in that direction. All right, and now I come to my dot. I can always start with an open dot and then just fill it in if I need to. So then I look back at my sign. Do I need to fill this in? No, I don't. It's perfect just the way it is. And that is how you graph an inequality.